The K-Mine software implements an algorithm for stratigraphic modeling of stratified deposits. A seam block model is created automatically, using seam indices in the database. We only need to know the sequence of seams and create the surface of one of the seams as a marker. The thickness of all the other seams up and down the section will be calculated from the wireframe surface of the bottom of that seam. In this block model, all blocks have different z-axis sizes. The height of each block depends on the interpolated thickness of a particular seam in the adjacent drill holes. This translates into the most accurate reproduction of the seam's shape in space. It takes just a few seconds to create a model for deposits with simple structures. However, in real life, deposits often have a more complex structure. For example, let's consider a deposit with two fault systems. The fault planes divide the deposit into three tectonic blocks: the block below, above, and between the fault planes. Within these conditional blocks, the position of the marker and the thickness of the seams can vary significantly. In many cases, there's also a displacement along the fault plane. This is the reason why we can end up with an incorrect block model when we create it for the entire deposit, without limiting the tectonic blocks by solids. So before we start, let's divide the existing solid by the fault planes into three separate solids. Let's call them Block 1, Block 2, and Block 3. After that, we enter these blocks as limits for creating a seam model. Also, we enter seam 11 as marker rock. If you selected the wrong marker position in the layer editor, or if the specified wireframe surface doesn't correspond to the seam, there's always a prompt message about the discrepancy. So let's create a new marker surface for each of the three blocks. For example, for Block 1, we will include the drill holes within the block and switch from the seam block model type to the marker horizon elevation type. Next, let's create the bottom surface of the seam we want to use as the marker. For Block 1, this is seam 12. We save the bottom surface of seam 12 to layer M1. Following the same steps, we create the marker surfaces M2 and M3 for blocks 2 and 3 respectively. For Block 2, seam 52 is the marker. For Block 3, seam 11 is the marker. Now let's switch to the seam block model mode and create the model. We can now analyze that the seam structure and the dip angle in Block 1 are different from those in Blocks 2 and 3. We can also see the substantial displacement of the position and the thickness of the seams at the contact with the fault plane. To analyze the seam structure in the required section plane, let's select the position of the section in the block model. We can also change the visualization mode of the model blocks by selecting edges. We can analyze or change the attribute values of any elementary block of the model if necessary. You can see that the block sizes along the X and Y axes are the same, but they can vary significantly along the Z axis.